Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to do a code review for you. And this is on Kaggle's Playground series, Season 3, Episode 19. And it's to do with forecasting mini course sales. So this is actually a time series problem. But rather than it being a univariate time series problem, it's more like a machine learning problem. So instead of solving the problem with a recurrent neural network or a stats model, we're going to use a regular linear regression model with TensorFlow. So there's a possibility that we could improve the score with random forest, but I didn't use a random forest. I only used TensorFlow. So it depends on how much time I have, if I feel like trying a different model, because last night I was working on it a lot. I even tried LSTM model, that's long short-term memory, but the score was actually lower with the LSTM. So we're just using a regular linear regression with TensorFlow. And this is with Kaggle, and what I will do is I will leave a link to the Jupyter notebook in the description box down below. So we made this on Kaggle's Jupyter notebook, and it's stored in my account. We're using the forecasting mini course sales. The problem statement is forecast on mini course sales, and the first thing that we want to do is we want to import the libraries. So we're going to import NumPy as NP, which creates the NumPy arrays and performs numerical computations. We're going to import Pandas as PT, which creates data frames and performs data processing. We're going to import OS, which goes into the system and retrieves the files. We're going to import matplotlib.pyplot as PLT, which visualizes the data. And we're going to import Seaborn as SNS, which statistically visualizes the data. We're also going to import Tensorflow as TF, and we're using version 2.12. So it's always important to know what version of TensorFlow that you're working on. And the reason why is because TensorFlow goes through a lot of changes, and because it goes through so many changes, a lot of its code is deprecated. So if you load something up on a certain version of TensorFlow, there's a possibility you could get deprecated code. So you need to be aware of that. Then we're going to set the random seed. And what we do when we set the random seed is it just gives you the same result each time you run the code. So random seed is tf.random.setSeed42. That's just a number I made up. Now we're going to use OS to get the files, and the files that are in the directory are sample submission, train, and test. Now we're going to use Pandas to read the files, and then when we read the files in Pandas, what we want to do is we want to timestamp the date. So we say parse dates equals 1, so that means column number 1 is your date, because you have to remember that in Kaggle starts with 0. So I just wanted to see what the columns were in the train so we can see which columns we have. We check for any null values. We don't have any null values, so we don't have anything to impute, so that's good. We want to check the info on train, so you can see we've got some integers, objects, and you can see the date has been time-stamped, so now it's date times 64. Print the unique values in the country. So the countries are Argentina, Canada, Estonia, Japan, and Spain. And you print the unique values in the stores, which is Kaggle Learn, Kaggle Store, Kaggle. And now we print the unique values in the products. So there's 3 books. So we check the test set. The test set is similar to the train set, except it doesn't have a number sold. Check for any null values. There's not any null values, so you don't have anything to impute, so that's good. We check the country, and it's the same as the test set. You check the store, it's the same as the train set. You check the product, it's the same as the train set. So now we have our submission file. So the submission file is going to be the ID and the num sold. Now we're going to establish the target. Your target is your num sold in your train file, and you're going to just pop that out. Now we're going to drop the ID because you don't need the ID. The reason why you don't need the ID is because every row is indexed in pandas. We're going to get the month from the date, so we're going to use pandas to do that. Train month equals train date.dt month. We're going to do that also for the test file. So now we can localize it down to the month. Then we're going to get the day, and we're going to use the exact same process, which I probably should have said train, train, so you could see the train file, but I didn't do that. And then now what we're going to do is we're going to drop the date, because you don't need the date anymore. And the reason why is because you've got the month and the day. The reason why I didn't set it up for the year is because you got if this is a time series data set, even though it's geared for machine learning, and so the date in the test file are not the same date as what's in the train file. So I was just worried that it wasn't going to have a positive impact on the reading, so I didn't get the year. So that's why I didn't put the year in there, because if you'll notice, in the year in the train file, it's 2015 to 2021 or something like that. And the year in the test file was 2022. And since 2022 didn't appear in the train file, I just thought it wouldn't be useful. But I suppose if I wanted to, I could go through and set up the year. But because you don't have any 2022s in the train file, I don't think that you're going to get a meaningful prediction. So now we're going to encode the object columns. We're going to use sklearn's ordinal encoder to do that. So now you see, instead of country, it's going to be a number. Store, it's going to be a number. The product is going to be a number. And then month and days are number as well. So now we're going to analyze the train file. So we analyze our target. So this is the target. And then we analyze the month. And you can see most of the cells were in December because that's going to be close to Christmas. And then we're going to analyze the date. And you see most of the cells are towards the end of the month. I think one of them is 30 and then 31. So most of the sales are towards the end of the month, and so that's when people get paid. So people will buy things when they get paid. And now what we're going to do is we're going to standardize the data, and we're going to use sklearn standard scalar to do that. Now what we're going to do is we're going to define our dependent and our independent variables. So y is your target, x is your train, and x test is your test. And then we're going to use sklearn's train test split to split the x and y data set up into training and validation sets. Now what we're going to do is we're going to import our Tensorflow modules. And then we're going to create a sequential model, and call it book sales. And so I just set it up for 20 neurons. But if you wanted to try to set it up for more neurons, you could. Because I was reading somewhere that really but yeah, if you want to try to set it up for more neurons to see if you improve your score, you can. So we compile the data, we set it up for a loss function as mean squared error, on optimizer as RMS proc, and metrics as MSE. We set up our early stopping, and we set up with model checkpoint. And then we train the data into the model, and so we history equals model.fit, xtrain, ytrain, epochs equals 100, validation equals xval, yval, batch size equals 32, callbacks equals early stopping NP, val loss, val accuracy equals model.evaluate, xval, yval, and then so we train it. And then our model val loss is 1362. And then what we do is we plot a graph of we plot a graph of the loss, so you can see the loss there. And then we make predictions on the validation set. We check our RMS, which is 36, which isn't too bad. And then we plot our actual values against the predicted values, and that doesn't look too bad either. And then we create a data frame that has the actual values and the predicted values, so you can compare the actual values against the predicted values. Now what we're going to do is we're going to predict on the test set, and is we're going to use the same methodology that we used when we were predicting on the validation set. I set up created a histogram of the predictions. So there's your predictions. And then we're going to prepare our submission. And when we prepare our submission, the submission num sold equals predictions. We're going to convert it to a CSV file. And that CSV file is what is going to be sent to Kaggle for scoring. So that's it. That's it for the code review. And I'm going to go ahead and leave the website to my Jupyter notebook in the description box down below. Whenever I submitted it to Kaggle, I got a 52, which wasn't fantastic. And I suppose if I wanted to, I could go through and look at other people's code and see if I can improve my score by looking at other people's code. I did actually late last night, I tried to set it up on an RNN to see if the score would improve if I set it up on an RNN, and the score didn't improve. It actually got worse. So in this instance, an RNN doesn't work. I suppose one thing that I could do is I could try to set it up on a random forest regressor and see if the score improves with a random forest regressor. But what I would do, me personally, if I wanted to improve my score, I'd go look through the sample code and see what the people who scored higher than me did. And then I would try to implement some of those techniques to see if I could improve my score. So that's what I personally would do. But I did work on this all day yesterday. I did try a different model. I tried LSTM. That didn't improve the score. So I'm just going to keep it as it is. So thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more videos for you in the future.